This is the worked example for writing loops. The subgoal labels for writing a loop are: 1. Determine the purpose of a loop. Then you will pick a loop structure, for, while, or do while, based on the purpose of the loop. 2. Define and initialize your variables. 3. Determine the termination condition, and then invert that termination condition to turn it into a continuation condition. 4. Write the loop body. Don't forget to update the condition to reach the termination. This means make sure to change the loop control variable somewhere within the loop. Here's our first worked example. We want to write a loop that will prompt the user to continue to enter numbers until a Sentinel value is entered and find the maximum value of all the values entered. Subgoal 1 is to determine the purpose of the loop. We know because of the instructions that we want the user to enter values until a Sentinel value is entered. Whenever it says a Sentinel value, you typically want to use a Sentinel loop, which means it should be a while loop, which is the most general purpose type of loop. Notice that we have the comments that we're going to use a Sentinel loop, which means that we need to have a Sentinel value and have a priming read before the loop begins. Then the loop should prompt the user for the values and find the largest. Subgoal 2 is to define and initialize the variables. Because we will be reading values from the user, we'll need a scanner. We're going to read in values into an integer variable called value. We need to be able to store the maximum value, so we declare a variable max so far. We have our prompt to the user followed by the priming read statement, where value is assigned the scanner's next int. Subgoal 3 is to determine the termination condition. In this case, we want to continue reading values until a Sentinel value is entered, so we need to pick the Sentinel value. The Sentinel value has to be one that is the same data type as the values we're reading, so in this case it needs to be an integer. 2, it needs to be a value that is not readily occurring in the data that we're reading. In other words, it needs to be a value that's not typically one of those that would be entered for that data. 3, we need to tell the user what the Sentinel is. Here we've chosen a value of -1, meaning that we anticipate the user will only enter values from 0 and beyond, and we want to find the maximum value. So in that case, the termination condition we want to end when the value read in is equal to -1. Now when we invert that to become a continuation condition, we want to continue the loop as long as the value read in is not -1. Now we're going to update the loop control variable to reach the termination. It's another read statement. So we now are prompting the user to enter in another value and reading that next value. Subgoal 4 is to write the loop body. Here we want to test if the value read in is bigger than the maximum value that we have so far, and if so, we want to replace that maximum value so far. Our loop now says, read in a value from the user. As long as the value isn't -1, continue through the loop. If the value read in from the user is bigger than the maximum so far, store that in maximum so far and read in another value. We will continue to read until the user enters -1. And when the loop ends, if max so far is greater than -1, then we know we entered the loop at least one time and the user entered in something that was not -1 and greater than -1. So that would be the maximum reached. If max so far is less than -1, then we will assume that no values were entered. We have another worked example for writing a loop that will add up the values 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 all the way until we get to 1 over 1024. Subgoal 1 is to determine the purpose of the loop and pick a structure. In this case, it is a summation loop. We actually know the number of times that we're going to execute the loop, so it could be a for loop. We're going to write it as a general purpose while loop and leave it as an exercise to convert that to a for loop. Here we need to define and initialize the variables. We will need one variable for the sum and another variable for each term. What data type should they be, and what value should term be initialized to? We probably want to have the sum and the term both be doubles so that we don't end up with integer arithmetic and a bunch of zeros. Now we need to determine the termination condition and then invert it. When do we want the loop to stop? We want the loop to stop once the term has processed 1 over 1024 and then ended. For this problem, you will notice the denominator rises in powers of 2. 2 to the 10th is 1024, so we know that this loop is going to add 10 exact values. We can say as long as I is less than or equal to 10, we want to continue in the loop. In writing the loop body, all we need to do is add the term to the sum. And then we need to calculate the next term. How do we calculate the next term? By multiplying that term by 1/2. The loop looks like this. We initialize sum to 0, term to 1.0, and I, our loop control variable, to 0. While I is less than or equal to 10, sum is equal to the sum plus the term, and then divide the term in half. Increment I. At the end, we want to print the sum. That's the end of this worked example.